Oh shit. It's tutorial time! Hello there. Welcome to the session. Hopefully that transition was smooth. Now, we're going to be doing some object-oriented programming today. This is going to involve another game. You know I like the games, doing the games this time around. And today we're going to be doing Snake. If you guys are familiar with the old Nokia phones or the old Blackberries, remember you played Snake on those? Well, we're making that right now. And that's going to teach us a bit about object-oriented programming and arrays and some of the other stuff that we'll need for quiz 1 and assignment 1. It's going to be very similar to what an assignment would look like. So starting off right off the bat, I'm going to get into some quick slides. Again, available for your screenshot. They're going to be on my courses. No problem with that. So let's just put those up right now and get to the first one. Yeah. So we're doing Snake. Quick rundown of what the heck is Snake. Well, Snake is a game. We play it on a board, like tic-tac-toe if you were here last time. So we're going to use a similar 2D array. But we've got a snake this time, and the snake moves around, it slithers around on our board. Our board also contains food, so it's got a tile which has 3 possible states. It's got food, it's got a snake, or it's got nothing. When the snake hits a tile with food, it grows by 1. When the snake hits a tile with nothing, it just moves to that tile. And when a snake hits the wall or itself, it's going to eat itself and it's going to die. So again, we're doing a snake game. And we'll get into the way that we take these game rules into the code right now. But before I move to the next slide and reveal it all, could somebody guess kind of what objects would we want in this game? What kind of things should exist in our game to facilitate making Snake? So what objects do we need to create? What Java files do we need? Anyone who wants to guess may come up.
Well, a class to represent the snake first, and one for the board.
Yeah, that's the great one there for a snake and a board. Now remember in tic-tac-toe we had the boolean which we used to represent either an X, an O, or an empty spot. Do you believe we'd need something similar for our tiles in the snake game? Well, for our snake game, we also have tiles, and the tiles do also have like a possible value, right? Like it could be one of any possible values. And our possible values are snake, food, or nothing. But here we might not want to use a boolean because it just might not be readable. Remember last time a lot of people were confused about that. So this time we're going to introduce a new concept called an enum, or an enumeration, which is just a list of possible values. And it's basically, we can literally list in English snake, food, or empty as our possible values. And if we're using an enum, well, we could actually use, we could create a tile object, or like a cell object, for every element of our board. So our board can contain cells, and the cells can have a certain type. So each cell could be a food, an empty, or a snake. And we'll see that when we get to the code. But first, okay, let's look into a few of the other requirements. A snake has to keep track of how big it is, and that's our score. A snake has to grow when it eats, and it has to be able to move around. So can anybody think of a way we can store which, like we can keep track of which cells the snake owns and how it's able to maintain itself? Because it's the snake's job, it's the snake object's job to keep track of which cells should be a snake and which cells should not be a snake. So does anybody have any clue how we could make the snake keep track of which cells belong to it? Well, a snake object, like any object in Java, holds fields. These fields hold values, right? So does anybody have any idea what kind of fields our snake would want to have? What kind of things? If somebody says it can have an attribute that gets updated when it moves, yes, and it can have an array. Okay, well those are both very good options. So if the snake holds an array, which can hold multiple things, and it holds this attribute, which is the array, which changes when it moves, it can update the array of what parts belong to it as it moves. And this is actually a crucial idea about the way that we do programming here, a crucial idea about Java. This crucial idea is that in Java, when we store objects in an array, we don't store the objects, we store a reference to those objects, right? So what if we have two separate arrays? We have the board and we have the array inside the snake. Both of these arrays will store cells, but the snake and the board will store references to the same ones. It's like two lists that point to the same things in memory. Like in memory, we've got all these cells. On the board, we've got basically a list of cells. And in the snake, we've got basically a list of cells. And when the snake modifies one of the cells in its list, the one on the board also changes, because all the board is storing is like a pointer to one of the cells in memory. We're going to see that in our code. But first, does that make sense to everybody that although we might have two separate arrays, there's going to be an array inside the snake, which holds the cells of the snake, and we have an array inside the game, which is the board. Does everybody see how those two arrays are pointing to the same objects in memory? We're making the game Snake here for anybody who has joined, and we want to make sure that the snake can track its which cells belong to the snake and which ones belong to the board. So everybody understands, right, that the arrays in both of the snake and the board are both pointing to the same object. When we have an array of cells in the snake and the array of cells in the board, we're going to make sure that those arrays both just hold references to the same cells. So when we update a cell inside of the snake, it updates on the board. Now here's kind of what we're learning today, the important terms and the useful facts. Arrays hold references, that's the one I was just talking about. We're going to use one of these killer combos, the things you see a lot in Java, which is a switch statement and an enumerated type, which we'll see as we get into it. We can use a switch and an enum to make a very nice, clean, readable piece of code. And then we'll be going back again, looking at dot equals versus the equals operator and stuff, the usual object-oriented stuff. Wouldn't it be easier to have the board array track the snake instead of the snake object tracking itself? Well, we're going to see why in our object-oriented setup. It might be a cool setup to have the snake track it, because that way, when we write our code, we can have a very easy setup, like for example, snake.eat, and then that can change the amount of stuff in the snake. We can easily track our score, because we can always track the number of cells in the snake. You can implement it in a bunch of different ways, but I think you'll find the way we do it can be quite elegant. It could save us quite a few lines of code, and it can be very readable and very easy to work with. Like, it's very logical, at least I believe, when you're writing the rest of your code, to have something like snake.eat to grow the snake. It's kind of a nice object-oriented syntax. But technically in programming, you can do it in a bunch of different ways. And you can have the board track the snake too if you wanted to. You could do the whole thing procedurally if you wanted to with no objects. But, well, again, since we're learning object-oriented programming, and since I think it's a clean setup, we can do it with the objects. Then, yeah, we have fields, which are variables that are part of an object. We'll use those a lot. And we'll do a lot of getters and setters. So here are the objects that I thought of to make our snake game. The important objects are a cell, which holds either a snake, a food, or nothing. The cells also hold the coordinates of where they are on the map. Then there's the game object, which stores the board and methods related to playing on the board. The snake object, which takes care of which parts of the board are the snake, where the snake moves, and when it eats, stuff like that. And then we use two enums for the type of the cell and the direction in which the snake is going to move. Then our methods are going to be our constructors, which are important. We're going to have a method in the game called advance, which is just taking like one turn forward, which we'll see. And we have a method called eat for the snake. So if it eats food, it grows. If it's empty, it moves. If it's eating a snake, it dies. Then we'll have lots of getters and setters, which will be able to get us objects to and from our snakes. So are there any questions just about the structure of our program before we get into the code? All right, so if you guys do end up having any questions about the structure, I'll be happy to answer them. How exactly does a switch enum work? Well, we're about to get into that in our code. That's not really a concept question. That's more a code question, and I'm glad you asked, Jordan, because we're about to get into that. So I'm just going to open up my IDE here, go back to my screen capture. I'm going to go to scene here and get rid of my get rid of that. All right, so now I've got my IDE here, and we're kind of ready to go. And let's just get into some of our basic objects, and we'll get into that. So create our new project. Right now we're still on tic-tac-toe. Can you repeat once again? You said both refers to the same objects. Yes, so the array, there's going to be an array inside of the board, and there's going to be an array inside of the snake, and they're both going to point to the same objects. We're going to see that better in the code. It's going to be easier to see. We can run it with a debugger, and we can show you, but what I'm saying is the arrays don't hold the actual cells. The arrays just hold references to cells in memory. and we will see that. So snake is going to be the name of my project. You guys don't have to name the project the same thing, but if you want to keep it consistent, that would be good. If you guys are coding along, I recommend you have the same names for classes as I do, because I'm going to give you guys a one last .java file at the end, which will give you a full graphics version of the game to play. So if you do want to follow along and stay tuned, I'll be sending you guys out a Java file with the graphics for the game as well. We'll write the whole game, but I'll just send out the graphics because we don't learn that in the course. And I'll also send you guys this doc right now, which contains somewhat written information about what we're doing today. That's in the chat. So I'm going to create a new class first. Let's start off with the very basics. Let's create the cell. Now again, for the cell, we said we needed to have certain things. So we needed coordinates. So let's just say private int x comma y. Those can be our coordinates. And then we can say private, let's say type. And then we don't have such a thing as type yet because we haven't created that, but we're going to call it, say, type. And type is going to be either food, nothing, or snake. Now to create this type, all we have to do is create a new Java class, but instead of a class, we want to create an enum. And now this is going to be very easy. We call it type, and here we list off our options. We can either have food, and it's all caps just by tradition. It's not really needed to be all caps. Food, snake, or empty. That's my enum, that's my list of possible types, right? These are the three types of things we can have, and then simply here we have now a thing called type. So our cell each cell has its coordinates and its type. Now if you were here last time, you'd know that when you have an object like this, these properties are inherent to every cell. So every cell has an x and a y coordinate and a type, right? This is why they're not static. They are not static. Now, what does this mean for how we can get to our x, y, and our type? Now, what is enum used for? Enum is used to list possible options. So when we say private type, we're just saying that it's going to be one of these three things. It's going to be either a food, a snake, or an empty. So that means the cell's type will just be one of the three things we listed in the enum. Enums are really easy. They just list possible options. But now, can anybody tell me, I didn't put static. What does that mean about these variables? What does that mean about x, y, and type? Can I just say cell.x? Is that possible? They're unique to each object, and I can't say cell.x. Exactly. So right now, we cannot possibly say cell.x. So what do we need to have in order to be able to access them? So we can't say cell.type. We have to have a cell object. Someone says getters and setters. Now I'm going to say that's wrong, and here's why. We do need a getter and setter, but not for that reason. So we need getters and setters. Need getters and setters because it's private, not because it's not static, right? So getters and setters apply because it's private. If these were public, you wouldn't need that. And now Fahim says this.x. But before I can access this.x, is there anything I need to do with this cell? What do I have to be able to create a cell, to create a new cell? A constructor, says Emma, and that is exactly right. Now, a constructor is just a special method which instantiates the fields. What does instantiate the field mean? Instantiates the fields means it sets a value to these variables. And again, just to go over it, the x and the y represent the coordinates that this cell has on the board, and type represents whether this cell is empty, food, or a part of the snake. And that's for our game. So now, if you're an IntelliJ, you don't actually have to write your own constructors. This is one of those features that makes you feel proud of yourself. You can just go to code, generate, constructor, and then you can choose what you want. I'm going to choose all of them, press OK. And the reason I can do that is constructors are very, very, very simple. Constructors are just methods that take as inputs the various things that make up your object, and they assign them to this object. So we're saying that we're creating a new cell. We're taking as input the coordinates and the type, and we're setting the values inside of this cell to be these. Is that very simple for everyone, how that works? And the syntax for a constructor is just public and then the name of the class. You don't have any return type. We don't say void or anything. We just say public cell, and we have our inputs. Now to repeat, type is either going to be food, snake, or empty. And since it's an enum, enum just means that it's going to be a list of options. The enum says a type is going to be a food, a snake, or an empty. And a cell is going to create a type. So it's just going to have one of those three possibilities. And if we wanted to add more later, like the reason it's better than a Boolean is we can also add something new here, like superfood or something, right? And that's going to be something we don't have to implement, but we can if we want to. And then we can add that feature. How do you create an enum? You just right-click, new Java class, and instead of clicking class here, you click enum, right? Very easy. Instead of class, you click on enum. Or you change here, see it says public class cell, you just type enum instead of class, and it becomes like that. So now we've got a public cell with its x and a y. Now before you guys were talking about getters and setters, and we do need getters and setters because you can see here these things are private. So let's generate those right now. Again, getters and setters are super easy. I'm going to write our first one and I'm just going to have auto generation for the other ones. Now a getter and a setter needs to be public to be useful. And actually if you look at my code suggestions, it even suggests that I just auto generate them. But I'm not going to auto generate them because I want to teach you guys. So I'm going to say public int get x. Right, this is going to get our x coordinate. We don't want inputs, we just want to return x. Now we don't have to say this.x because there's no local variable by the name of x. Diane is asking what's an enum. It's a list of options. If anybody wants to elaborate in the chat, I encourage you guys to help each other out in the chat because I do have to get through the content reasonably quick. So if anybody wants to help add more detail to that for Diane, then you're encouraged to answer in the chat. All right. Now we have got our public int get x. That's a getter. Very simple getter. Getters are easy. So getters are easy. We use them to get private stuff. They're also great for pickup lines. If you want to flirt with CS students, you can be like, I'd use a getter to access your private fields, and then you can instantly get a date with any CS student. That will be useful for you guys. So get x. Now setters are simple as well. We can just set x, and that's a void. We don't need to return anything. And then we can also put an int x as the input, and instead of return, we just say x is equal to x. Now that doesn't make sense, right? So we specify that we're setting the field x like that. We say this.x. Since we have a local variable of the same name as the global variable, we say this.x to set it. Now that's getters and setters. They are super easy, guys. You don't have to worry about getters and setters. Literally so easy that you can just generate them. You do code, generate, getter and setter, and let's just generate a getter and setter for the rest of our stuff. Bam, now we have auto-generated getters and setters for all of our things. These things are so easy, you don't need to write them, don't waste your time, just make IntelliJ do it for you. And if you're in Eclipse, then you can sit there and manually type it. Yushan says, why do we need to set x? We probably don't, but it's good to have the getters and setters because that way we can have access to these coordinates from outside. Actually, if we wanted to be very smart, we could get rid of the set completely. We never have to set x or y. So we could just get rid of these completely and not worry about it. And that way our program is very safe because that means that once you place a cell on the grid, you cannot move it. And that's actually very smart. We don't need to set them. I just wrote the setters to give you guys an example, but this is a better program if you can't set those things. As far as I'm concerned, I don't remember having to ever set them. All right, so now we've created cells, guys. We've written our first class. This is all we need for this class. It's literally done. This is it. Now we can move on to the game class. Does anybody first have any questions about the cell class, or do you guys want to move right on to the game?
Yeah, I'm just a little confused about what do enum do? Like, what is the difference between a Java class and an enum?
Sure. So in classical Java, an enum can only contain just a list of stuff. It can just contain a list of possible options. It's nothing more than this. An enum can have the states you list. So this enum can take the form of food, snake, or empty. Nothing else. There's no methods. There's no fields. Literally, an enum is just a list of options. It's as simple as saying, it's basically a map between numbers and words. It's for us as developers to have an easier time working. Because when it actually gets compiled, it turns into nothing more than like 0, 1, 2, 3 as our options. It's just when we are writing our code, we might want to put an English word to one of these possible states. So it's a tool that helps us make readable code in giving human readable names to just a list of options. Would we be able to use an enum on assignment 1? I don't have assignment 1 details right now, and I don't know if enums are going to be covered. I'm covering them here because they're very useful, and we're probably going to see them at some point in the course, but I don't know if we're going to see them as early as assignment 1. But they're probably not going to come up super soon, and they're not a big focus of this. But they're very easy, and I thought may as well teach them now rather than having annoying statements. I'm literally teaching you guys enums right now for the sake of making this code more clean, not because they're really easy. It's because this is the easiest way to do it. Now, will assignments be hard? Yeah, they'll be hard if you didn't prepare, but since you're here, you're probably not going to find them very hard. Now, I'm going to create a new class for board, and I'll even use my fancy transitions that I rarely use to get to that. Or I guess our game class is what I call it, so I'll call it game. And our game class will be now responsible for holding an array of cells. So we'll now have cell, and it's a 2D array. Now, this looks familiar if you made tic-tac-toe. We have our 2D array of cells, and it's going to be called board. And on this board, we'll be responsible for certain things, right? We'll be responsible for maintaining it and for putting stuff on it. So why don't we right now get that dealt with, and we'll also get the name of our game dealt with. I like to have a static string for the name of our game, just because it's a cool thing to do, and it also shows what static is. So we'll have a static string name, and I'm going to call it something like maybe Sauder School of Business Simulator. Because it's full of snakes, and that should hopefully be relatively understandable for you guys. Now, our static string's name can be accessed, again, doesn't matter which instance of your program you're running. You can just access this like without instantiating a game. You don't have to start the game to see the name. Similarly to how if you guys, let's say, had like a PS4 at home, you don't have to start up GTA 5 to see that it's called GTA 5. You can see that just by the nature of the game. That's what static means. It means it's applicable to every instance. And now here I can just right-click it, click Generate Getter, because I want to be able to get my name. I don't want to be able to change my name afterwards, so I can make a getter. And since I really don't ever want to change my name, I can also call it final. And final just means I'll never be able to change it. It's going to be that forever. You cannot change it while the code is running. So that is what final means, and that's there now. And that's going to be our first method. Now, before we do much else, why don't we actually create the code to start our game up? That's called a constructor as well. But this time I'm not going to generate the constructor because it's going to be a little bit more complicated. I'm going to call it public game. And there's actually going to be 3 inputs to our game. And now these inputs I just came up with. This is not because every snake game has to have it. It's just something I like. So we're going to have int size x, int size y, and int food odds. Now these 3 ints are going to be used to set up our board. And this is also going to introduce us to constructors. But first thing we want to do is we want to have a random number generator. To do that, we just say rand is equal to new random. Not random. Come on, there we go. And it's going to automatically import that for me. The random number generator, all this is going to do is give me a source of random numbers to use to fill up my board, well, randomly every time, so we don't play on the same board each time. That would be boring. And I'm going to say board is going to be a new array of cells. Board is equal to new array of cells. And it's going to be of size x and size y. Seems understandable for you guys now. We did arrays last time, so I'm not going to go into a ton of detail about how these work, but I am going to use a nested for loop to fill this up. And this part is the part where you guys want to pay attention, because this is where it's going to be somewhat new stuff. Not this part yet, but just bear with me while I write the for loop. I equals 0, I is less than board.length. I++. This will be on the quiz, this kind of stuff, so just be careful and pay close attention here, because this looks a lot like some questions that you might see on the quiz. Now for int j is equal to 0, j is greater than board.length, or because board0.length, or actually board I.length if I want to be very good, j++. Now, common quiz questions are going to be about arrays being manipulated with objects in them. This is exactly what we're covering today. So a quiz question might look like, well, what we're about to write, and it might ask, what does this code do? So why don't I write it, and I ask you guys what this code do, and that can be kind of like a quiz practice. A little bit like a quiz practice, not exactly. I'm not allowed to give you guys exact questions, but this is about as similar as I can get in a real-world application. And we have to understand that rand.nextInt with a bound of food odds, okay, that equals to 1. So what does this do? This says the food odds are like how likely it is that a cell is going to be food. I'm going to say how likely is this number to be 1. So if that number is very small, it's going to be very likely that there's going to be food in a given cell. And if the number is very large, it's very unlikely that there will be food in a cell. That just makes the game easier or harder, basically. So now I'm going to say board I j is going to be equal to a new cell equals new cell, and it's going to be I, j as the coordinates, and its type is going to be type dot food if it's one of the food cells in here. And that's how enums work as well, and this is going to be type dot empty if it's not food. So, similar to a quiz question, could anybody tell me what they think this does? What is this board going to look like after this runs? And sorry, Yuri, I cut you off there. If you have a question, you're welcome to ask.
Yeah, I have a question, but I went to wait.
Okay, sure. So if anybody here knows what this code is going to do, this is what it's probably going to look like if you're writing a quiz. You're going to have some sort of array like this that's filling up, and it's going to have, a board full of empty objects and a board of food. Now let's say that food odds is equal to the number 4. So it's going to have a random number generated between 1 and 4, and it's saying, if the random number between 1 and 4 is 1, the cell will be food. So can anybody tell me roughly how many of, let's say, 20 cells will be food if the food odds is 4? As like an estimation. Well, yeah, exactly, because about 1/4 of them are going to be full of food. Now, you're not exactly going to have questions identical to that in the quiz, but they're going to be kind of similar. They're going to might be a little bit harder than that. Why does random food need to equal 1? I just put it like this because like the smallest number for food odds would be 1, because then it would generate a random number between 1 and 1, and it will be 100% food. So if food odds is 1, it's always going to be food. If food odds is 2, it's going to be food half the time. If food odds is 3, it's going to be food 1/3 of the time. You see, equal to 1 is just kind of a convenient way for me to do it. If I were to be very smart, I would make equal 0 maybe, but I'm not very smart, so that's what I'll leave it as. So now we've filled our board. Yep, sorry.
The question that I have is about the concatenate 4. So the runtime of that is gonna be all n power 2, no?
Yeah, assuming that both of the size x and size y are going to be n. Remember, big O notation is basically how many times we visit each element, and we're not focusing on time complexity in this session at all. It's not even something we're thinking about, because we're not going to have a game of Snake of size 1 million by 1 million unless you're really advanced at Snake, and in that case, respect. But obviously, I don't know about that. Anyways, it's going to be actually big O of size x times size y as the time complexity. That's going to be the official statement on that. How do you know food odds would be between 1 and 4 in that example? Because we'd specify that food odds is equal to 4, and we'd say that rand.nextInt 4, with the upper bound being 4, is equal to 1. So if the next random integer up around 4 is going to be equal to 1, it's going to be food. That's how we'd know. That's how the question would look. It wouldn't say food odds, it would say 4. That's something you could expect to see. Now, before we continue making the game, we're going to want to be able to create a snake. So why don't we start creating the snake object now? Unless anybody has any questions about this part of the game. We're not done making the game object yet. It's just right now we've reached a point where we need to make the snake. So anybody have any questions about the game before we move on to the snake? Could you repeat the bounds rule? Well, yeah, sure. So when you do rand.nextInt, you supply a bound int, which is the largest int it can generate. If I don't supply any bound, it's going to go up to like 2 million something, and we don't necessarily want one food in every 2 million cells. So instead I say there's going to be an upper limit of food odds, so whatever number it generates is going to be between like 0 and food odds, and then we're saying that if it's 1, it's going to be like a 50-50, it's going to be more, it's going to be a lower odds of having food. That's all it means, and then when you guys have access to the graphical version of the game, you'll be able to play with that a lot better. Okay, so in fact, actually, if I were to make it smarter, I'd probably say equals 0, but I haven't read up on the random API recently, so it might be better to be 0 or 1. Anyways, let's move on to writing the classes and getting to the snake class. So,
sorry, I have a question.
Sure, what's up?
But what's the type of cell IJ and type?
Sorry, could you repeat?
That type? Yeah, I mean, what's the type of the cell? Like,
the cell.
Why we need to write as that form?
Okay, so the cell is going to be either food, snake, or empty, and that's what we defined in our game rules. We know that every cell on our board is going to be one of those 3 things. And when we create our cells, we're setting the type, which is a field of the cell, to be one of those 3 options. And we define our options here. And now in snake,
I didn't see the main part.
In snake, that's going to be used. So how do we write our snake? Can anybody give me any hints as to what fields our snake is going to want to have? Well, public, yeah, so there are going to be public things, but what fields is it going to have? So what kind of variables are going to be in its snake? An array with its coordinates, its length. Emma, you're completely right about length, except I feel like we can simplify that because the array that Lena suggested, it actually includes the length. And you guys are saying head and tail, that would be a linked list, and we're not doing that yet, but we'll do that in a future session. So we're going to work with an array here, and we're going to use the array's length as its length. So we only really need one thing here, and it's going to be it's private cell, boom, snake. I'm going to call it snake just because that makes it a little bit understandable. Like the snake is made up of cells. This is a biology class now. You get the point, right? And there's actually another thing that nobody thought of, but because I didn't bring it up. The way the snake game works is that the snake has a direction in which it will always move, right? So the snake will always be moving in some direction at every turn. It can never stay still. So we also need to keep track of which direction it's going in. Does anybody have any idea for a good data type we could use to store a direction? It's going to be up, down, left, or right. Does anybody have any idea what we could use to store those possible options? An enum, says Naomi, and Naomi is exactly right. This is another situation in which an enum is useful. So we can create a new enum here. It's going to be an enum, and it's going to be called direction. Direction. And this direction enum is going to store, up, down, left, right. That's where the snake wants to go, right? Because our direction is just the direction in which the snake wants to move, and the snake will always remember what direction it wants to go in. So I'm going to say private direction. And those are going to be our two main fields. And in fact, our duration doesn't really need to be private, right? Because we don't really need to hide our direction from anyone. We don't want to, people can mess with it. We want the user to be able to change it. So since we don't care who modifies this, we make it public. Now we don't want the snake to be public, right? Because let's say somebody's hacking our game. They could just make our snake super long and get a high score. We don't want that. But the direction, the user is allowed to play with the direction. They're allowed to modify the direction so it can be public. So this one's going to be private since we don't like cheaters. And this one is going to be public because we don't care the player has control over that. That's just kind of one of our, it's not a Comp 250 thing per se, it's just kind of a logic thing, a software engineering thing, computer science thing, about deciding whether something should be public or private. This is one of those situations where I cannot conceive of any possible reason why modifying direction would be a security threat, so I say public all the way. You don't have to make those kind of assessments in Comp 250. That's something you'll do when you're working in your internships and stuff. But it's still something that's nice to think about to understand why we have such a thing as public and private. And so now we have a direction and we have a cell array of snake, right? Now, can anybody have an idea of how we want to make a constructor for our snake? Well, everybody knows that when babies are made, they start off with one cell. So why don't we take that inspiration from biology and we apply that to our snake? So we'll have a public snake constructor, and that snake constructor let's just take an input of a cell. That's going to be the cell that it starts on. And we're going to take an input maybe of the direction it's going to start moving in, because it's got a destiny, right? It's got a destiny to move in a certain direction. That's where it's born to move. And it's got a cell which it starts off with. These are arbitrary. I came up with these for no reason other than that's what I thought of. You can do whatever you want for your constructor. It'll work anyway. This is just how I thought of it. Now, the cell the snake starts on is going to want to be a snake cell, right? So we can say cell.setType, type.snake, because this cell is going to become part of the snake. We want to set the cell to be part of the snake, right? But we also want to make sure that the snake knows that that's part of it. So we can say snake is equal to new cell, and it's now we can do a special kind of array instantiation where I put the curly brackets. That means that whatever is inside the curly brackets will be in my array, and that's going to be the cell C. Not in here, but in the curly brackets. Now it's going to say that that's going to be an array whose contents are that cell. It's just going to be of length 1. And now direction is going to be dir. Right? We just give it the direction it was born with. Nice. Does this constructor make sense to everyone?
Can you repeat please the snake variable?
Uh,
A new
so-
cell, the way you have you did it, it's the first time I've seen it.
Okay, so the snake variable is an array of one dimension of type cell, right? So we
Yeah.
see that. Okay, now I'm just instantiating it, and I'm saying it's a new array of one dimension, and these curly brackets just mean that whatever is inside of the curly brackets is going to be what's inside my array. So here I'm just listing what's inside the array. Does that kind of make sense?
I see. Thank you.
Cool. So yeah, here I'm just listing that one cell. So now our snake is born. It's of length 1. Is there any function that our snake is missing right now? I'm going to knock the easy ones out for you just because I don't want you guys to have too easy of a time answering. What happened to dark-themed IntelliJ? You're right. I should really stop burning my eyes. Let's fix that right now. If you want to change a theme in IntelliJ, you just... Beautiful. My eyes are no longer burning. Great. All right. So, now we have our snake object, and I'm going to give a couple of basic getter methods. First, we want to be able to get the head of our snake, because we're going to have lots of cells. We need to keep track of which one is the head. Now, I've got an easy solution for this, which makes it, it's kind of like brain dead easy. I'm just going to say whatever is the first thing in our array is going to be the head. So I'm going to say get head, if only it were that easy, and return just the first thing in the snake array. So snake add 0. Right? Easy peasy. Whatever is the first thing in the snake array is going to be our head. And now we also want to be able to get the size of our snake. That's how we're going to do our scoring. So it's pretty important. And we'll say public int size. And that's going to be our return snake.length. Right? That's just the length of our snake. Now we're missing one thing. And that's what happens when we eat a cell. So why return the head? Well, sometimes it's useful to know where the head of our snake is, right? Because we might have an array of snake of like length 10. So how do we know which of those cells is our head? It's just shorthand. Do I ever use getHead? I don't even know if I ever use it. I don't think I ever use it in the code. It's just in case you were wondering. And it applies to it in the future when we're doing linked lists and stuff. Do those have a head? That's why it's there. It's mostly to explain the theory of linked lists in the future. Okay. So here, we also want to have a method for eating when we eat a cell. And I'm going to ask you guys for a bit of input on how you think we should write it, but I'm going to put the specs first. It's going to return a Boolean, and the Boolean is whether or not it died, or whether or not it survived after eating it. Eat, and it's going to say cell C. What's going to happen when the snake eats a cell? Now, can anybody give me an idea of the possible options here? It's going to be like 3 possible options, right? Because there's 3 kinds of cells it can eat. Can anybody give me an idea what kind of syntax I can use to very nicely write 3 different options for what happens when it eats? It needs to be able to eat a snake, a food, or an empty. Check the type of the cell to see if it's snake, food, or empty. Yeah, but do we have a certain... here, I just put this comment to explain what it has to do. The wall we'll handle in the game class, actually. We don't have to worry about the wall right now. We assume that whatever cell it's being passed is not null. If it hits a wall, the cell will be null. So we'll handle that somewhere else. We'll get a null pointer exception, and we'll use a try-catch for that. So we only care about food, snake, or empty. Does anybody have an idea how we can make a certain syntax for that? Could we use a switch statement with enum values? Exactly what we need to do. So here I can instantiate my switch. I can just say switch c.getType. So it's going to create a switch based on the type of the cell. That's a pretty common syntax that you'll see. And now we have different cases. So we can say case food, break, case... Well, it already suggests me what cases there are, right? So if I just start typing case, it's going to give me them suggested to me. So there's going to be case snake, and there's going to be case empty. Now, case snake is going to be the easiest, right? Because I said we return true if you're okay and false if you died. So if it's a snake, we just return false. We don't care. It's the other cases which are more complicated. So in the case of eating food, what do we need to do? We need to increase the size of our array to include the cell that we just ate because our snake has grown. Now this can be a little bit spicy and a little bit challenging sometimes. I'm also just going to return false if it's none of those things. I'm going to assume you died if it's something else. This is a switch case block for somebody who's asking what is the syntax here. This is saying that based on the type, we'll go into this one if it's food, we'll enter this one if it's snake, and we'll enter this one if it's empty. So this code here runs if the cell has food, Code here runs if the cell has snake, and code here runs if the cell has nothing. Now, can anybody guess at what we have to do once we encounter this cell? Maybe I'll give you guys a hint with a variable declaration at the top. We're going to have to create a new array. We'll have to have that. So what do we do with this new snake in the case of food and in the case of empty? Okay, so in the case of food, it has to grow, right? So we have to do something where the snake might grow by 1 with its new head on the spot that the cell is on the food is on, and its tail unmoved, right? So that means that index 0 of snake has to be the new cell, or I guess the cell that used to be food. Rest of the snake has to shift back in index by 1, and the array has to grow. Does that make sense to everyone? Now, this might be hard to implement. This might be confusing. You might have no clue how we're going to do this. It's okay. Let's just be really stupid about it, and let's just do the first thing that comes to mind. It says the array has to grow. So new snake, let's just make it an array that's 1 bigger. We can say new snake is equal to new cell, and instead of the previous length, we'll do snake.length plus 1. Right? Very, very simple, very stupid. It's the easiest thing that comes to mind, right? Does it make sense to everybody? Our snake is going to be 1 longer, so our new snake is going to be just a new array of cell that is 1 longer than our previous snake. Does that make sense to everyone? All right. So yes, again, we just do the first thing that comes to mind. Now here it says that the index 0 has to be the cell that used to be food. So we'll just say that new snake at index 0, new snake at index 0 is going to be the cell we just ate. So it's going to be C. And then we can say C dot set type snake, right? Because C is no longer food, it's now snake. Instead of creating a new array when we want to cell, could we also use array lists instead? We are using array lists, we're just not importing them. In your assignments, you'll find you're not allowed to import things like array list, especially at the start, because we're teaching you how to make them. So if you think about what an array list is, you might see now that there's quite a similarity between the code I'm writing here and an array list. But we're not going to call it an array list, we're just going to call it a snake array. But it's actually an array list. All right. Again, the reason we don't just import array lists is because we're not allowed to on assignments. This is a course that's supposed to teach you about data structures, so we make you do them manually. Sorry about that. You got to learn to do them manually at some point. Now is the time. All right, so we've put index 0 as that cell. We've set the type of it, and now we have to just copy over the rest of our snake. Now remember, we just keep the rest of our snake in place. So all we have to do is we can just say, for int I equals 0, I is less than new snake.length, or let's just say snake.length, because we're just copying them over. We're just iterating over snake. I++, again, we're just iterating over our snake, right? We're just taking everything from our old snake, and we're saying new snake at I+1, so whatever is in the next index of new snake, shifting it over by 1, is equal to snake at I. Very simple stuff. We're taking whatever used to be inside of the snake at index I, and we're putting it into the I+1th index of our new snake. At the end, we just say snake is equal to new snake, and now we're done. We've grown our snake by 1. That's how array lists work. Array lists add an item, and then they copy the array over to a new array. Does that kind of make sense to everyone? If you have any questions about what we just did here, please ask them. You're going to see it a lot in assignments. You're going to see it a lot in quizzes. This is a heavy part of the course right here. It's just copying stuff over to a new array, growing an array list. This is very important, so make sure you pay a lot of attention to it, okay, guys? If any questions, if you don't come up with some now, ask them on Piazza, ask them in office hours. Come next time, ask them. Just make sure you understand that very well, okay, guys? So new snake is just a temporary object. Yes, Elena, you are exactly right. New snake is just an object that we create because we still have to read from our old snake. See, we still have to take stuff from our old snake. We can't just throw it away. So we can't just say snake is equal to new snake right away. We have to still copy everything over. That's why we have a temporary object. All right, I'll let you guys formulate some questions if you need to now. And in the meantime, I'm going to talk about the empty case. Now, the empty case is similar, but it's a bit easier. We don't even have to grow it. So we can just say, we can create another temp one. We can say new snake is equal to a new cell, and it's just going to be snake.length. It doesn't have to grow, right, because it didn't eat anything. So it's just going to be the same length as before, but we have to just shift it over. Now we can say new snake at index 0, is going to be C. And then we also say c.setType snake. It's very similar because we absorb the new cell, even though the new cell is still not, it's not food, but we still absorb it into our snake, if you know what I mean. And now we just have to deabsorb another cell. So we can say let's say for int I equals 1, I is less than new snake.length I plus plus. It doesn't really matter if I use snake or new snake because they're the same size. And now I just say new snake I is equal to snake of I minus 1. And you'll notice that this just copies over everything from the old snake to the new snake except for the last thing. And now we just say snake at index snake.length minus 1 is just going to be empty, right? Because whatever was in the snake in its last index is no longer a snake. It's just going to be empty now. Does that kind of make sense to everybody? We take the snake, we copy over everything but the last element, then we just say snake is equal to new snake. New snake. And of course, I want to be able to return true in both of these situations because it didn't die, so return true. True. Instead of break, we can change for a return statement. And this one also returns true because we didn't die. If anybody has any questions about this, this is the most important part, so please ask away if you have any questions about this. And this was the eat method. Oopsies, forgot to put the big title up. If you guys just scrub through the timeline here for the eat method, this is here. Line 50, we're saying the old tail last cell of the snake is now empty, right? Because we don't want the snake to grow forever, is now empty. So we need to just change that the last bit of the snake, the one that we moved from. So the cell we moved away from, the one that we removed from our array, it also was set back to being empty. Does that make sense? Because not only do we care if it's in the array or not, we also care if it's empty or not. All right, perfect. So that's our eat method. That's the hardest method here. If you have any more questions about it, you may still ask, even though I'm going to move on to our next method, which is going to be called the advance method. And it's going to be our last method, I believe, before we can actually play the game. And I'm going to send you guys a file, which will give us a graphical interface and graphics for the game that we can play. So again, this is our last method before we're done. And all we have to do is move on and play the game. So for our last method, this is what happens every time the clock ticks. Every time that our game moves to the next, basically the next part of the game, our next session. Every time the clock ticks, the snake moves in a direction and it goes there. It's actually a pretty easy method. It's going to be called public boolean. It's going to return a boolean to see if the snake died or not. Advance. And now what's it going to take as input? Well, we already have our snake and everything as a field, so it doesn't actually need to have any inputs. But wait, before we do that, we never created our snake. So let's add a field for it. We'll say private snake, or let's not even make it private. Do I really care? No. We'll just say snake key. In our constructor, we can actually make our snake itself be part of our game. So we've got our snakey, or I'll just call it snake so that it's consistent with my other code. Then we just have to create our snake. So if you remember our snake constructor, can anybody tell me what inputs our snake needs to be created? Like, what does it take to create a snake? Direction, and of course the cell, right? The cell that it originates from. So I'm going to put a bit of shorthand here. I'm just going to put the snake squat in the middle of our thing right away. So I'm going to go into our game, and I'm going to say here that our snake is equal to new snake, and it's going to go into the middle of our game. So it's going to be put into board at board.length over 2, and board at board.length over 2 dot length over 2. Looks weird, but that, and also our direction will just start as up all the time, because I'm too lazy to do anything else. So the snake is just going to start by moving up at the start of our game. So what is this weird syntax? This syntax is saying that we just, in the squarely in the middle of the board, we just put the snake. Easy peasy, right? So that creates our snake. Now we have everything we need to write our advanced method. We've got our snake constructor in here. We've got our board set. Everything is ready. So now what are we going to do? We're going to say our coordinates. We need the coordinates of our snake, right? So we're going to say int x. This is why we needed our getHead method, by the way. Int x is equal to snake.getHead.getX. Now see, we're using multiple getters here. Int y is equal to snake.getHead.getY, because our snake moves relative to its head. That makes sense, everyone, right? We're just using our getter methods right now to get the coordinates of our snake. And now here is the fun part. We're going to put a try catch. We're going to put an index out of bounds exception e. So this is for the case if it gets off. So this says if the snake tries to leave the board, it dies. Remember, returning false means it dies. And now, in every other case, I'm going to use some crazy modern Java syntax. Now, if you're using an old version of Java like Java 1.8, I can't guarantee this works. This requires a new version of Java, but it is cool syntax. So just get ready. It's going to look really cool. So switch snake.direction, snake.direction, and I will explain the syntax after, but I'm just going to show you how clean this can be. It's going to be a switch on snake.direction. Now, why is it saying it doesn't like it? Well, we don't have a default branch yet, right? But it doesn't matter, because we're going to cover every case. We're going to say case up, and then this lambda, it's an arrow, and it says snake.eat board x y minus 1. And that's just because it moved up, right? So the y coordinate, the way that Java GUIs work is that negative is up. And now we're just going to do 1 for every case. So up, down, left, and right. And now this is Java syntax you probably won't see in the lectures because it's new syntax. It's something that you might not have seen before. So down we'll do y plus 1. Right. Left we'll do x minus 1. And right we'll do x plus 1. Plus 1. And what this statement is actually saying is that in the case, it's shorthand. It's shorthand syntax for saying that we're going to return the output of snake.eat board with this if the value of direction is up. If the value of direction is down, we're going to return this method call. Does that make sense to everybody? It's a shorthand. Instead of saying if snake.direction is equal to up, return snake.eat board x y minus 1, we can do this simple version. I'm going to write the full version now to just show you how much faster the syntax is. And the full version would look like this. It says if snake.direction dot equals direction dot up. I'm only going to write the first one because it's going to be so long. Direction dot up, then we return snake.eat this, right? It's long, and now we can have to copy paste this. Now we say else if, and then, you know, it just goes on forever, right? We don't like that. So I'm going to comment that out. I'm just going to put this comment here to commemorate how much code we'd have to have written. Star, that's how much code we'd have to have written in order to make this same statement. But this does it in only 5 lines. Does this kind of syntax make sense to everybody? It's not something you need to know for the course. It's just I want to tell you guys something cool. So this is some cool syntax that you might want to pick up. Right? Cool. That's our little bit of modern Java for today. That's lambdas is what these are called. And these say that in the case of up, we return that. Does anybody have any questions now about our game? Because I think it's just about almost ready to play. Just 2 more method calls we need to do. Public void set direction, we'll set the direction of the snake. So we'll say direction D, and we'll say snake dot direction equals D. And our last method we need is get score. So we'll say public int get score, and we'll say return snake.getSize or snake.size, right? So now, are there any questions about our game code, or do you want me to send out the file and get you guys onto the app, the game that we're gonna play? I'll take that as no questions, so we can move on to our gameplay. Where did snake.direction come from? It came from this file right here. I sent you guys the GitHub link. You can just download that .java file. I'm going to do that on my Chrome right now. So just going to go to snakeapp.java. I'm just going to copy paste all of this into a new .java file. So I'm just going to take everything here. It's code that you don't need to know. You're not responsible to understand this for Comp 250. The reason I didn't teach you guys during the tutorial is because you don't need to learn this for Comp 250. It's to make a graphics app. You don't need to know how to do that. Snake app is what it needs to be called. Now in here, I just paste in this. Game G doesn't like that. What is it not like game? I have a class called game. Yeah, cannot resolve symbol game. That's interesting, because in my code I expect I do call it game as well. Let's see. Did I call it something? No, a game is literally game. Did I not put it in a package? Oh, that's because I put this in a package snake. That's why. So if you guys created a package, then that's great. If you didn't, you can just remove the package declaration at the top. Now if I run snake app, you'll see where direction comes from. It comes from me typing W, A, S, or D on the keyboard. So now my snake starts like this. I change my direction by typing a letter, like D I typed there, and then it moves around. And you can see that my snake.direction changes every time I press a key. Hopefully you guys can play this as well on your end. You should be able to play it with the code we wrote. And we can see that our snake will move around. It moves around based on its direction. So again, it does exactly what our code said. It's going to move in the direction that is specified to it by our keyboard press, basically. And every time it advances, it's going to move in the direction that it's set, and it's going to play the game. Does anybody have any questions about it now? Any questions about anything related? You're welcome to ask. Sorry, it says very basic, but it says add configuration when I try to run the code. If you try to run the code, you can just right click and click run. It's not going to show up at the top until you run it. So you just right click in the class and you click run. That's how you run it for the first time. And will the recording be posted today? Yes, it will. And if you're confused about anything in depth, then you're welcome to come on Friday's session. And on Friday's session, I will, of course, it's going to redo the same content, but I'm going to have a better explanation of it because I'll have feedback from you guys about what was confusing and what wasn't, so I can do a more concise job on the Friday session. But of course, if anybody has any questions at all now, it's your time to ask. So if there's anything specific you'd like to be reminded of, or if there's any specific syntax which confused you, now is the time to ask away.
Just how did you make the last file run? Like, what did you remove from the code?
Sorry, could you repeat the question?
What did you remove from the graphic code? Like, did you remove the package snake sentence?
Yes, I just removed the top line that says package snake. That's because in my project, when I was making it on my own time, it was a package snake, and now it is not. And then it says, it looks very laggy. That's correct. That's because it updates every 500 milliseconds. If you wanted it to be at a nice smooth 60 FPS, I don't think you could do your inputs fast enough. Are we supposed to know all that Java syntax for the quiz? You're responsible for some of it, not all of it. You're not responsible for this modern Java. So the one I showed you at the very end in the game class, this one with the lambdas, you don't need to know this. This is extra. This is stuff that I think you guys might find useful or cool. But this part you don't need to know about. The rest of it is within the scope of Comp 250. But for the quiz, it's not really going to be mostly about this stuff. The quiz is mostly going to look like this. And the quiz is also going to look like, where is it? The quiz might look something like this as well, like here. The quiz will look kind of like this stuff. I don't think the quiz will look a lot like this. The quiz will probably not have anything like that on it. This is more modern. This is how people in 2021 might write more Java code. It's something that you'll see if, for example, you go on GitHub and you look at random people's code. Can we still use that syntax? Yeah, you can if you're using a new enough version of Java. It should be acceptable. This is just something you might see so you don't get confused by it. If, for example, you're writing code and you find something on Stack Overflow that looks like this is so that you can understand what the heck it does. And it is like a more modern standard version of it. And yeah, there we go. That's our simple game. We used an array list essentially to make our snake, and then the content from here should apply relatively well. Not just this one. The content from the last tutorial is also quite quiz related, so you'll see that it was. If you understand these completely, you should be able to understand the concepts on the quiz. Static versus non-static is big, but I think you guys have a pretty good understanding of it. And yeah, any further questions, I'm happy to answer. Otherwise, I'll just enjoy playing some Snake until you guys have asked all that you have to ask. Okay, cool. I'm assuming no questions then. If you guys would like to... actually, no, I probably won't do it in the same recording. I was going to do a tutorial on uploading to CodePost, but I'll probably do that separately in a different recording. Anyways, that's all irrelevant. I'll see y'all another day. Farewell. Enjoy your time. Good luck on the quiz. Good luck on the assignment. Hopefully should not be too killer for you. Then I have office hours on Wednesday if you have any questions about anything. Next session's on Friday. Farewell. Enjoy your day. Have fun playing Snake. Enjoy.
Sorry, Sasha.
Oh yeah, sure. What's up? Love the last.
I was just waiting that you finish because I want to go back to the big O notation.
Okay, sure. What's up?
My question is, how do you have any tip to switch from brute force to big O notation? Like normally I'm gonna do also a for inside of a loop inside of another loop, but how we can switch from that mentality to try to keep it
Okay, that's a great question, and I think it's something we'll cover a lot more. We're going to have whole entire tutorials dedicated to just that coming up in the future in not too long. Because right now, remember, our first assignment and even our second assignment usually has no marks for time complexity. It's a much harder topic, and we're going to learn fast algorithms. But I can tell you the gist of it now so you can approach it from the right perspective, and that's that you want to touch as few things as possible. Now, what do I mean by that? I mean, let's take an example, a very famous example. You're going to find this on a lot of computer science interviews of finding something repeating in a set of arrays. In fact, maybe I could even find it on like LeetCode. We can say like find first repetition repeated character in array. It's a super common like coding problem. I can find it on Geeks for Geeks here, right? So you find the first element that repeats, right? Now, you can tell me, right? Obviously, you can do it with nested loops, right? Like you can think of that in your head.
Yeah.
Okay, so to get you thinking about time complexity, I'm going to tell you about another method. So instead of doing nested loops, we have something called the tortoise and the hare. We have a slow loop and a fast loop. Now, the slow loop is going to go through every single element one by one, but it's going to cut down our time complexity because we're also going to have a fast loop. So let's say we've run for 6. We've compared 6 to every other number, and we've determined, or let's say we've compared 10 to every other number, we've determined it does not repeat, right?
Uh-huh.
So now, do we still need to use 10? Or do we know that it never repeats?
No.
So we never repeat 10. We know we check the whole thing against 10. So what we can do is we can use a fast pointer. The fast one will compare 10 to everything else. It'll say, 10 is not equal to 5, not equal to 3, not equal, whatever. 10 is useless, right? We've determined that. Then after we've determined that 10 is useless, our slow pointer will move forward by 1. And from now on, we'll only start at 5. And we'll say, is 5 the same as anything in here? Oh, yes, it is. But that way, let's say 5 didn't repeat, we would be iterating through a smaller array every time we advance, right? Instead of doing everything compared to everything, we'll be comparing 3 to every other thing, then we'll be comparing 4 to every other thing, and we'll get a gradually smaller one every time we compare, right?
Okay.
So that's faster, right?
Yeah.
And the mentality there is that we made an assumption. We said, we can assume that once we've touched something and once we've compared something, we don't need to touch it again. And then we took that idea that we don't need to touch it a second time. We saw we're wasting time when we compare 10 a second time. So let's stop wasting time and let's just get it out of our array the next time we compare it, right? Does that kind of make sense?
Uh-huh.
Yeah. That's our mentality for cutting down our time complexity. It's just thinking about what assumption can we make to make this go faster. Is there any assumption we can make to make it go faster? Now, there is a faster solution to this, and it uses hash maps, but we're going to see that in the future of the course. So you don't have to worry about hash maps right now. You'll learn all about them near the end of the course. They can make it go faster, but until we learn about hash maps, the double pointer solution is quite fast.
Okay, got it. Okay, cool. Excellent.
Yeah. And Comp 250 should prepare you we're going to tell you about all kinds of data structures and all kinds of stuff that's going to help you cut down on time complexity. And by the end of Comp 250, you should be about geared up for a software interview where they ask you, how do you do something with decent time complexity? By the end of Comp 250, they'll ask you, how do you find the first duplicate? And you'll be able to tell them that you can use a hash map and you can do it very quickly. Or at least you could tell them you can use double pointers. Right? And
Okay,
that's...
cool.
Yeah, that's what you need to know, but don't worry about it yet. It's okay. First assignment, first quizzes, you won't see this until a long time from now, and by the time you see it, we'll have done hours and hours of lectures and tutorials on it, so you'll be well prepared.
Okay, cool. Excellent. Thank you a lot, man.
Yeah, for sure. Enjoy your day.
You too. Bye.
Farewell. Alrighty.